Hello, thank you for having me here this morning, and I appreciate the opportunity, and thanks for the introduction. Following the earlier speaker when we were talking about trains, I wonder if any disruptive technology could avoid the beeping at 3 o'clock in the mornings that, apart from being electric, the diesel's not a problem, but I think that the hooting at the junction near Adamstown is keeping me awake at nights. Gives me the opportunity to think about buildings that think, and that's my topic today. As you can see, my position, which Evelyn didn't mention, it's supported to some degree from Lend-Lease and John Holland, so I liaise with them, and hopefully in the near future we'll be building some great research projects. My background isn't really looking at buildings that think, and this was a topic that was proposed to me, and I'm quite happy to have a chat about it this morning. In terms of innovation, I think there's a lot of innovation that happens under the radar, as it were, in terms of how construction organisations actually develop innovation in the projects that they complete. My mind went back to all the tender scenarios or the tender bids that I've been involved with in the long distance past, and of course it crossed my mind that the winning tender always incorporates a great deal of innovation. Now, this innovation tends to become the property of the client or the owner of the building, so it often goes, as I said before, under the radar. But it's worthwhile thinking that builders do innovate significantly, and that led me on to this presentation this morning. Really, the builders do think, and they incorporate innovation. So innovation primarily, I guess, and I'll give you, as academics love to do, a definition of what I think buildings that think are at the end, but just a taster. It's involved with the process and the product. So I'm going to give you a couple of ideas that are drawn together, because when I think about innovation, I really think about the small things that happen quite ordinarily, but brought together create the innovation. And I also thinking in terms of, in a disruptive way, that innovation, again, in my mind, really comes from reflective practice, the opportunity to actually sit back and think, I believe, creates innovation. I'm not sure that it can be actually structured, but having said that, being an academic, we always like models and templates and those sorts of things. But anyway, I shan't give you any of my background. I think Evelyn's given a picture of me. So as a researcher at the University of Newcastle, I've been putting my mind to productivity and innovation, as I said before. I spoke with the other people, some others in my school, and I gave them the opportunity because I felt this might be a good opportunity to showcase some of our ideas. So a few other people were involved in the ideas, the generation of the thoughts, and much of what we've come up with today, I think, is proving to be quite a strong theme that underpins the entire event, which is good. So productivity improvements and innovation, really what I'm about, require change. So despite unrest and discomfort caused by an industry's need for reskilling, perhaps, retraining or engineering, there are key things that we need to think about. I think primarily and firstly, I'd like to mention off-site manufacturing. For people of my generation and background, the term prefabrication will send shudders to their core as they think back to a time in the UK when inconsiderate and inappropriate prefabrication development required people to live, work and learn in uncomfortable conditions to satisfy the priority for high-density, quick-fix accommodation. That's a thing of the past. In Australia, of course, we find that land use is heavily constrained through climate consideration, but use the right materials and configure the product correctly using contemporary off-site construction techniques and perhaps robotic technologies learned from manufacturing to develop the product and final building would service a growing city like Newcastle with sensitive accommodation and other amenities. So I use the word sensitive with caution from the perspective of sustainability in the environment. and also in terms of developing a civil society with the appropriate mix of space utilisation as a top priority provided to all. So I think that's important. By way of a recent example, the Guardian newspaper in the UK identified a Chinese construction company that is building houses using 3D printers. They were mentioned yesterday. In addition to this innovation and providing a lead in sustainability, the construction material used is a mixture of cement and waste building material. So waste building material is the key there from my perspective. So if you can imagine a robot that to some degree produces a product similar to Play-Doh, something that young children would use, and you may have seen this in your past, and it churns out the walls, the roof members and constructed material as if it was a string of sausages, you wouldn't be too far off the mark. So what are buildings that think? I mentioned before that with the use of robotics, refocused labour, the clever use of materials and configuration on a singular or urban scale, buildings could generally be more sensitive to our environment, provide primary purpose of shelter, secondary purpose, security and comfort. But really the question comes back to, do they think? So 2 or 3 aspects. When I was a trainee quantity surveyor some years back in the UK, I was taught that bringing some materials in construction could cause damage to the actual fabric. So, for example, aluminium doesn't go too well with cement mortar. Over time, the cement will eat away the aluminium. So they're dissimilar materials. That was the term that we'd use. But new understanding of materials technology stands to provide great improvement in the built environment. Cutting-edge research in concrete technology, for example, the use of alternative constituents, I mentioned that earlier in the Chinese example, even fibre cement, self-healing concrete, a research project in my school, shows ways that the environmental footprint of new buildings under construction can be produced. In the same way, longevity of materials reduces pressure on limited resources, and a final building configuration of materials that incorporate advanced thermal insulation, ensuring limited heat gain in the summer and heat loss in the winter. These concepts, I believe, will become the norm. Material science will provide essentials that we require in any home. They may be a long way off, however, they could soon be a reality. Consider battery technology. This was mentioned just earlier on, and its enhancement over recent years. Hybrid cars, lightweight batteries, immense power are not unusual on our roads, or won't be soon. Consider for a moment technology that would allow the fabric of the constructed building to generate power, heat, cooling or light. Soon every building will become its own power station and less reliant on the grid or centralised power stations. Photovoltaic cells that were mentioned yesterday by a chap from the CSIRO, and heat pumps are commonplace in modern buildings. They're pretty unattractive at the moment, but I imagine that soon these will become standard roof tiles, configured to look like roof tiles or roof sheeting, more sympathetic to the eye. Glazing is set also to benefit from photovoltaic technology. Windows are now being developed that actually are solar panels. They create power for the building's occupants, but at the same time, they let light into the room, as we have here, and allow people to be warmed in the summer days and generate electricity for consumption in the coolness through the day. Self-cleaning windows on high-rise buildings are not a thing of the past, nor are they science fiction. Self-cleaning materials modelled on microscopic flora and fauna will provide a solution to the abrasive effects of atmospheric pollution on the building fabric in the not-too-distant future. LED technologies in television displays. In nature, luminescent materials are being investigated, and currently late-model televisions display panels utilising this technology. It won't be too far away, I don't believe, when internal lighting in buildings using organic materials in the same way will provide cost-effective, energy-effective and scope-effective aspects in the building environment in facilities. Already structured wiring, wireless technology, Bluetooth, which I understood from yesterday's speaker was invented here, or Wi-Fi incidentally, was invented here by CSIRO some years ago, enable us to access our houses and computer system remotely. We have the capability to operate heating, lighting, security and many other features from a home from anywhere in the world where an internet connection. Movement sensors in rooms that switch on and off lights. We can run pre-programmed heating at the same time to save energy. A book chapter from two of my colleagues and others in engineering caught my attention recently. It sets out research modelling improvements required to existing buildings to meet a more severe climate that is predicted in 2050. This was alluded to yesterday by the CSIRO presentation. Some simple retrofitted materials and components provide part of the solution. Double glazing, replacing floor tiles, those sorts of things to benefit from heat gain. However, when you look at the book in some detail, you find some quite interesting and pertinent aspects associated with this presentation. The book titled Weather Matters for Energy turned my attention to a possible future home that receives complex weather data, both past and present, and makes decisions related to heating, cooling, ventilation, safety and security. It reacts accordingly in advance, putting measures in place that conserve finite resources. For example, switching from local wind turbine generators to its solar panels that would be generated or supplemented through the glass that I mentioned earlier. In more challenging scenarios, it could close shutters to avoid particularly inclement weather, storms, and could prepare emergency lighting for consequent use, perhaps. Radio frequency devices, RFID, they're currently used for many applications, from parts identification in complex oil and gas facilities to simple wayfinding applications in shopping centres or nursing homes. They're a reality. As the technology becomes more and more advanced and more complex, following perhaps even nanotechnology, they'll become widespread in our buildings that think, I believe. An example provided by Monash Swarm Robotics Laboratory suggests that micro quadcopters that utilise the principles and behaviours of flocks of birds, for example, will soon be able to perform complex tasks together. Because they're ultra small, they can fly into small openings and in a building future directed to undertake repairs or maintenance that would all ordinarily represent risks to people. Robotic tracking models and its associated software that I've seen currently enable these similar small quadcopters to autonomously track fast-moving objects and even catch them. Whilst this may not be relevant to buildings that think, I suggest it provides an insight into a future for buildings as yet unrecognised. Complex buildings require more and more attention, and the RFIDs that I mentioned before of the future will ensure secure information, asset life management, gate valves, for example, detailed wiring systems will know how they're functioning. They'll also know whether they need repairing, and they'll also know how they're integrating with other materials. Another example that I'll just drop in that hopefully will blow your mind, as it did for me, a writer from the journal Intelligent Buildings International takes the notion that in a future he perceives RFID technology could be connected to the nervous system of human beings. The writer sets out a scenario where an implant provides a communication shortcut between a person's brain and the building where the person currently resides. So, not putting too fine a point on the principle, I think we can foresee a time in the not too distant future when, if you recall, the Borg from Star Trek would be actually here. So there are a couple of other things, and I'm conscious of the time, so I'll just skip through and show you a slide. The new space building, where we're hoping that some of the innovations that we're talking about at the university will become incorporated. I mentioned in the paper earlier on about multiple information sources and knowledge sources in the construction process. So condensing these down, a colleague of mine suggests that you need data mining techniques to absorb all this information and then sort out the relevance of that information to enable buildings that think. So you can see this scenario here, you get increased efficiency, it's faster and cheaper to build, more sustainability and less waste. So this researcher has envisaged a time when materials management in the production of the building is absolutely fundamental. Another example where RFID tracking, current technology is utilised, which enables a person's movements to be monitored. And in this scenario, you can see they got very busy up in the middle area. That was their home. And they're just trialling, a colleague of mine from the School of Architecture and Built Environment, just trialling some jawbone technology that could be utilised in buildings that think, not just in the production, but also in the management of the buildings in their whole life. So what are buildings that think? I said at the outset, I gave you a little teaser. Buildings that think, here's a definition. So you can see that they're a consequence of the construction industry rethinking their production processes. So I've given you a couple or three examples of where these can help in, as I've said there, in their configuration, in their fabrication. Obviously, they need to be environmentally sympathetic. Cutting technologies, as we've seen from previous presentations and mine, will play a bigger and bigger part in buildings that think. And they will help reduce the footprint over time of that building. One thing I didn't mention that was in my thoughts in preparing my presentation today is the length of buildings. They'll have to last a lot longer than they do now. Currently, we're looking at 50 to 75 years. I think we're going to have to push those out to 200 years or more for the life of a building. And we're going to have to look carefully at how we can reconfigure those buildings for multiple uses through their life. And I think that right now we have building information modelling that will help out in that. So there's the bibliography if you're interested. A quote that I found at the end in my investigations from Winston Churchill. I did say to my wife I might try and put on an impersonation. I won't do that. You can all imagine it, I'm sure. So Winston Churchill said, "We shape our buildings, thereafter they shape us." And I think that's quite a pertinent thing to take away from every aspect. And maybe we shape our worlds, thereafter they shape us, I'm not sure. So there we have it, that's my presentation. Thank you very much, and I hope I'm roughly on time.